Good evening. It's nice to be back after 3 years. I really missed all of you. I missed the city, and I missed us coming together as a community. And on that note, happy anniversary, Code Blue. Thank you so much for Kana, Kentaro, and of course Tessie, wherever they might be hiding right now, for starting this 10 years ago. I always loved coming here and connecting with the same people. On that note, I'm speaking yet again on telco security today. 5G. Last time, I forget what network generation I spoke on, probably 4G. So we keep finding new vulnerabilities in each new technology that's added to mobile networks. Specifically today, though, I want to focus on the elements of a 5G network that can act as a case study for all other technology that we're rolling out right now. 5G networks are converging with other technologies. They're becoming cloud environments. They're becoming highly automated. And so are your systems. It doesn't matter what industry you're working in, you are also going into the cloud and you're adding a lot of automation. So there's some lessons to be learned from how telcos roll out mobile networks today, lessons that you want to apply to whatever infrastructure you're working on. My name is Karsten. I've been working as a mobile security hacker for many years through my company in Berlin in Germany. But I've also regularly been asked to help make mobile networks more secure from the inside. So, and I can tell you, hacking mobile networks is not easy, but trying to make them secure, that's another challenge entirely. And my team and I, we love going back and forth between breaking something and then thinking about what it takes to structurally fix those issues. And we've been basically doing this through all the technology generations that today make up mobile networks that are basically patchworks of all of this. None of this has ever been switched off as far as I can tell. And of course, I'm not doing this alone, and even this is just a small subset of the geniuses I'm working with in Berlin. Today, 5G. So what is a 5G network? There's different versions of 5G infrastructure, depending on where the company is when they start rolling out the 5G network. Most companies, let's say here in Japan, there would be SoftBank, KDDI, and Docomo, they already have a mobile network. So the first step in rolling it out is to take their 4G network and just put some 5G antennas on it. So the actual technology doesn't change, just the radio waves change, so to speak. Right? That does not do much about security risks, so whatever security risks you had in 4G, you still have in 5G then on the core side. What's more interesting to me is if you build a network completely from scratch. I believe here in Japan, for instance, Rakuten Mobile is doing that. They did not have an old mobile network, so they basically don't have anything to latch onto in terms of legacy. Instead, they're building it completely from scratch. And that is where everybody will ultimately be heading, building real 5G networks where the core and the radio waves are 5G. Some of those will be more open than others. And today, generally, we want to focus on those, but I'll say a little bit about these upgraded legacy networks as well. Starting, in fact, with more the legacy and then going more into what we currently see and what all mobile networks at some point will look like. And like I said before, this has a lot of lessons to be learned for other infrastructure, everybody who goes into the cloud, everybody who adopts automation. But why do we have to speak about mobile security at all anymore? Thanks to very good research and the GSMA and 3GPP's efforts to respond to it, today mobile security standards are, as far as I can tell, pretty much free of security issues. There's good encryption, there's good authentication. So why do we still worry about mobile security? In fact, the type of hacking that we did around 2G, where you just stick up an antenna and you listen to your neighbor's phone call, that had already been eradicated with 3G. So we're multiple network generations better than easily hackable networks. And not just listening on your neighbor, intercepting has become more difficult. The other threats like impersonation, which is related to fraud, has become much more difficult, and so has denial of service. Denial of service is never going to go away entirely. This is a radio technology, so you can always jam it. But with that remaining risk, the mobile security standards we have today are pretty much as good as we needed. And I believe the same is true for instance, Wi-Fi. WPA3, which is now being rolled out, looks like the standard to keep, right? But mobile networks are not just these good ideas of how to improve the standards. I'm just showing these as illustrative. All of these are ideas that were introduced with 5G to make these networks even more secure. Mobile network, first of all, are very complex in IT environments, and that's what we're going to focus on today, to then ultimately show how you can go through a 5G network to, again, impersonate users, to listen to their phone calls or read their text messages. Much more interesting in the world of two-factor authentication. Text messages are a great theft target. How you can take down the network. So in about 20 minutes, we'll have seen how all of this is possible, even though the 5G standards are so much better than previous standards. And in fact, this evolution towards better mobile standards should not distract from other technologies running in mobile networks that are sometimes heavily outdated. When 2G was introduced in the late 80s, it was introduced together with SS7, an interconnect standard. We're still using SS7 today for 5G networks. There's just no alternatives that have quite the same global rollout. But even that we're not going to talk about today, but we want to focus on the technical infrastructure underpinning these networks. So a mobile network, even with the best standards, has to be built somehow, needs to run on some IT environments, and the IT environments are now moving into the cloud. So most of what we're going to talk about today will be around those technologies. Let's start, though, with the present state. So a 4G network that was upgraded to 5G. When we do pen tests in those environments, we find them to be heavily behind the curve in terms of IT security. Missing patches, missing hardening settings, weak authentication. Basically, like you would have built a normal IT network in the 90s or early 2000s, mobile networks that we have today are suffering from those same issues. And they're not going to go away. Like we said, those networks just get new antennas now, and they become accessible to all of you. So mobile networks basically rely in their security on being shielded away from everybody. As soon as you have access to those IP networks that run those components, you can usually use standard exploits, weak passwords, and all that standard pen testing stuff to penetrate the network. Right? So let's look forward. What's the evolution now? What's changing? Two things are mostly changing. Well, three, but I'm not really interested in this aspect here that makes networks basically cheaper. Everybody else is, though, right? Cheaper is always a good reason for rollout. But cheaper in this case comes packaged with cloud technologies, so virtualization, often in form of containers running on Kubernetes, as well as automation. And there's a good reason you would want to use both of those. In fact, you can't really deliver on the promises of 5G without a high level of virtualization and automation. And one of those main promises of 5G, of course, is low latency. Low latency means you need data centers very close to the user. So having a central data center somewhere for a country isn't enough anymore. In Germany, they're building a mobile network right now. It takes 500 data centers for a small country like Germany to deliver on the low latency promises. Right? So the old paradigm of building and operating mobile networks doesn't work anymore. And let's remind ourselves, what was that old paradigm? You build out infrastructure slowly across an entire country, and then a small team of really experienced, let's call them Linux administrators, logs into each of those boxes and configures them. This is a once-in-a-generation thing, right? You're rolling out this network one step at a time, and then you never touch the running system anymore, right? I mean, you might touch it maybe once or twice a year to install software updates at most, right? And you do this on a few dozen nodes in your core network most of the time, right? Everything is centralized, everything is stable. Now let's come back to the 5G world. 500 data centers, each of those running multiple functions, so we're talking tens of thousands of functional units deployed in the country, and all of those constantly changing, because another promise of 5G is of smart edge, so computation happening closer to the customer, gaming, automotive, something more industry focused, whatever you can think of as a future application of 5G, you don't have to build it into the network today, you can just roll it out as you need it. So tens of thousands of functional units that are changing regularly. So you can't manually, with that small team of Linux admins, administrate it anymore. Instead, this is all scripted. Right? Mobile networks are today built in clouds using scripts. So that's the first component that is highly virtualized. The second component is that these scripts, of course, need to be created in some kind of automated pipeline. And now the attack surface, of course, has changed dramatically. The first big changes, you go from dozens of units to tens of thousands that potentially have some security issues. And you go from a small group of experienced people to literally hundreds of developers that are somehow involved in these automation scripts. Right? So a much, much broader set of both technology and people that impact the technology of your mobile network. And again, substitute mobile network with whatever infrastructure you're involved in, and I think the same lessons still stick. We're broadening the trust base, so to speak. So let's look at each of those in turn. First, virtualization, and then automation, and remind ourselves what security implications that has. Starting with virtualization, and specifically containers running in Kubernetes. In theory, this is a security upgrade, because you can have very fine-grained software controls over what each of those containers can do. Right? Each of them lives in their own little sandbox, kind of like an iOS application you can imagine. And so the operating system, in this case Kubernetes, can put very heavy restrictions on them. Unlike before, where everybody was running in a flat IP network. Right? So in theory, this is a security upgrade. If it weren't for container escapes, so if your little container is heavily constrained, if you find a way of breaking out of that container and taking over the Kubernetes running underneath, then you get much higher access rights than you're supposed to have. And that sounds like science fiction, breaking out of containers, at least with virtual machines running in more traditional cloud environments. We don't usually see virtual machine escapes. These are very rare and require heavy screw-ups by whatever manufacturer of the hypervisor. With Docker containers, it's actually relatively common to see escapes. There's a whole range of configuration settings. I'm just listing the ones that we find to be insecure regularly here. And each of these configuration settings can make your one Docker container the possible escape point for somebody to take over your entire network. Some of these are obvious. I mean, it's in the name. If you give the privileged container attribute to a container, of course, you're allowing it, in this case, to speak directly to the Linux kernel of the host operating system. It's an easy shortcut. If you're moving something from a virtual machine to a Docker container, you want the software to still kind of behave like in a virtual machine. You just give it all access rights, basically. Speak directly to the operating system. That gives you a root shell right away through multiple ways, right? For other attributes, it's not that obvious that they're insecure. And the color shading here suggests how often we find them. The lighter shaded ones we find sometimes, the darker shaded ones almost all the time. So for instance, this host PID attribute is set, at least in some Docker containers, in almost all the environments that we're scanning. And this is basically a way to query the process space of the host operating system. Not necessarily to do much with those processes, but just to basically query what all is running. And information-wise, that's relatively boring. You can predict what's running in a Kubernetes cluster, right? Mostly Kubernetes and nothing else, right? But this gives you the side effect of also being able to kill those processes, now the host processes, right? So you're sitting anywhere in this mobile network on some test machine, say, that's running next to production machines. You can kill every single one of these production machines if this attribute is set. So for critical nationwide infrastructure, that, of course, is close to doomsday. If then other attributes are set in addition, for instance, sysp trace, you can also take over the processes, so start reading the information and whatnot, right? Let me just give you one more example before moving on. The one that I found the most surprising, being somebody who has worked more with virtual machines than with Docker containers, and that's the last one here, network access. So in virtual machines, how do you give network access? You usually just bridge to the network that the host has access to. And it's almost as if the virtual machine sits next to a computer on the same network. They have separate interfaces, they have their own IP addresses and all of this. In Kubernetes with Docker, it doesn't work like this. If you bridge to the host network, you're sharing an interface, you're sharing an IP address, right? So just by bridging, you allow, for instance, the container, the guest, to ptrace or to network capture all the communication of the host, right? And then, because Kubernetes are trusted environments, internal networks, a lot of communication happens unencrypted. So just by giving network access to a container, you basically let the guest sniff all kinds of privileged information that's sent to and from the host, and also you allow it to connect to interfaces that are only bound to a local host, for instance, the Kubernetes admin console. And up until pretty recently, that was not authenticated at all, right? So you connect to something that is only bound to a local host, no authentication, you take over the entire Kubernetes cluster, right? So, of course, that raises the question, how do you give network access in a secure way to Docker containers? And we won't have time to go into that in detail now, but basically, you have to build your own software-defined networks, build your own firewalls into that. It's complicated, right? So, long story short, as you're moving from virtual machines to Docker containers, if you're not touching your software, you have to set some of these attributes, and they basically break your entire security model. So there's a lot more work involved in that transition, then lift and shift into Kubernetes, and many vendors don't do this. And if there's just a single vendor in your deployment who doesn't do that, that's the escape point to then break out of the Docker container, right? So for the hacking journeys we'll look at in a couple minutes, this will be one of the key elements, breaking out of a Docker container. The other aspect, just briefly touching on it, we said automation is key now, right? Those hundreds of developers creating scripts that then build tens of thousands of functional units in those 500 data centers, right? Some threats theoretically go away. You can't phish a Linux admin anymore now. There is nobody who has basically superpower control over an entire network. That was replaced by automation. But other risks become more pronounced. Especially risks of accidental data leakage. There's a lot more software happening now. Stuff gets uploaded to public repositories, sometimes accidentally. Stuff gets literally pasted in the wrong places. I have a problem with this code. Can somebody help me with this snippet? And then you see some password in there and whatnot, right? We've all seen this, and mistakes happen. But mistakes happen more often if several hundred people are involved in creating your software. Every single one of them has some likelihood of making a mistake. So keep that in mind as kind of the second ingredient as we're now talking about the results of us testing mobile networks in what's usually referred to as red team exercises. So this is when a company invites us to break into their infrastructure with no prior information other than, I guess, the name of the company. Right? So really the same perspective that a criminal would start from, right? And we do this regularly, and the results I'm going to share next are from real exercises, but I should point out they're not from one company. I'm kind of blurring the results of multiple exercises to respect the confidentiality of each one of them. So far, so good? By the way, before getting into this, I want to make sure that no questions stay unanswered today. And having spoken in Japan a few times before, I know you don't like to ask questions in front of everybody else. Take a note, send me a message later, find me later, whatever way. I want your questions to get answered, right? So make sure if anything is unclear, note it down. We'll talk about it later, right? Okay, so red team results. Each of these journeys will happen from left to right, basically starting from nothing at all to achieving whatever hacking objective you had. In this case, spy on the customer. So basically gain back that capability that on the radio side we lost when 2G networks were upgraded to 3G, where we couldn't easily spy on people anymore. Let's gain that back somehow, right? In this particular journey, what happened? We find some development web portal, somebody trying out whatever new code. They know it's not going to be necessarily secure, but this application has access to absolutely nothing. It's specifically segregated on the internal network so that it can't access any customer data. It can't even access any other machines, right? It's, from the perspective of the developer, completely safe to put experimental code in there, right? So, of course, we hacked this machine and we're stuck. It's basically a dead end. There's nothing we can do from this machine if it weren't deployed as a Docker container on Kubernetes, right? So, of course, one of all of those attributes we listed earlier was set in this machine, as it would be. I mean, they didn't give it much thought what you need to configure. So we break out of this one container, and then all of a sudden have access to everything Kubernetes has access to, which needs to be at least a superset of everything any of the Docker containers running in it has access to, right? So very far-reaching access on the internal network. Now I should point out this is the IT side of this mobile network, not yet the telco side. Often there's a big barrier between it, but we'll get to that later. Turns out you can spy on customers, telco customers, without even touching the telco network. So we break out of the container, and we start scanning the internal network. It's a modern enterprise, so it has plenty of APIs. We start messing with those APIs. One of them, if you send it wrong data, sends you a nice debug log, and that debug log had enough information in it to basically give you admin access somewhere else, right? And say, oh, why don't you try this to debug? Whatever mistake. Mistakes happen, right? So we look around, where do these credentials work on, and we find some data warehouse. So not a production system, more a, let's create some statistics for, we don't know, marketing purposes could be. Not sure what the system was, but it was outside of the telco domain, getting a stream of information from the telco nodes. We log into that, and we see all the customer SMS flying by. So somebody can build statistics. Customer SMS, of course, is enough to break into online banking, whatever else, two-factor authentication, right? So really good hacking objective met. And again, only using relatively straightforward techniques that as a red teamer you would have used in a non-telco environment as well, right? So first hacking objective met. Let's look at the look at the next one. Accessing customers' private information. So not the dynamic information like text messages that flies by, more their static information, their registration data, right? So this hacking journey reuses some of the components we already had from earlier and then adds to it. So we're still broken out of this container. We can still scan the internal network. So one of the other things we're finding is an internal source code repository. Everybody has them. You're not supposed to put anything like passwords in there. In this case, they kind of did, they kind of didn't. So this was a repository basically you used to build new machines. And one of the things you need is an etc shadow file, right? It's not passwords, but it's password hashes. One of them was crackable. So now we have a password that is deployed to all the new machines. They could change it. They don't necessarily. So we use that to log into another database, still on the IT side, not the telco side. In this case, that includes all the registration information, the bank accounts, the address, everything people put down when they first sign up for this company, right? So again, no magic here. This is very straightforward IT hacking and arising from the cloudification and automation of this network. next hacking journey. We want to actually finally get to the telco network, right, which we haven't touched at all. We find on the internet a description of how you can VPN into generally telco elements, and turns out they're using this technology. Now, it's not bad to put the source code on the internet, of course. In fact, that's encouraged, right? So the more people look at it, the fewer bugs happen in, for instance, the VPN software. But a VPN is only secure as long as you don't give somebody the credentials to log into it, which we already had from an earlier step in this hacking journey. So put these things together, an understanding of how this VPN works to log into the mobile network side of things, plus the credential from earlier. So we do that, and we're again kind of in a dead end, in kind of some statistic monitoring server. This wasn't a very good credential, so we're not allowed to access any actual telco elements. This is we are in the right network, but again, in the dead end. So you know what happens next, of course. We break out of that container, again, using one of those settings that are known to be insecure and yet found everywhere. And that gives us control over everything running in this Kubernetes. And that happens to be one of those, let's say, 500 data centers, right? Anything running in that, we can access now. And this, of course, works for every single one of these 500 data centers. So you can do whatever you want on any of these devices, including everything we said earlier, like reading text messages, right? And then finally, of course, it doesn't require any other ingredient. You can take down the entire mobile network from that, right? Either by just killing the processes, or maybe more destructively, ransomwaring everything and making sure that people in this environment don't have mobile access for some time, right? So all the way to the end, we didn't do anything telco specific, right? This is just hacking websites, breaking out of containers, finding credentials laying around, and all of those mistakes will be made, and not just in telcos, right? Which is why I think this is a good guiding story for whatever industry you are in, cloudifying and automating right now. So what's next then? What do we need to do to fix those problems? First and foremost, and kind of obviously, fix those container configuration issues, right? That list I gave you as insecure, you can just make that an audit list, and if any container has any of those settings, don't allow them into your Kubernetes, right? In fact, that's relatively easy, given that all of these containers come through some kind of CI/CD pipeline, and then some repository for artifacts, and they're deployed relatively automatically. At any of those points, can you check for that configuration and just say, no, this is not allowed in our environment, right? Make sure to include your test environments, because like we saw, the line between testing and production is relatively blurry in these environments. So even your test environment need to meet some minimum standard. But generally, getting containers to secure is relatively straightforward. Everything else, though, is a little bit more difficult, and not just for telco networks. Easy to put advice like this on a slide. I guess today people would call this zero trust. But that's hard, right? It's easy to speak about it at a conference, but it's actually hard to implement any of this advice consistently. And like I've shown you, if from your 10,000 elements, one of them deviates from the standard, that's your weakest link. So let's start a little bit more bottom up. What are security controls that we as red teamers hate, that make our life a lot harder? And we're really going back to the very basics here. Patch your systems and harden them. Make sure access to administrative interfaces is more restricted than just connecting to the network, and do something around monitoring on the endpoint or in the network, doesn't matter, but have some visibility that maybe somebody is in the process of hacking you. Now, these are so old, you would think we jump back to the first code blue 10 years ago, but still today we need to talk about these topics because they're not implemented in networks, and especially not in mobile networks. And starting with the first one here, patching and hardening. It's actually surprisingly hard to do patching and hardening, both in old networks and in the networks of the future. for completely different reasons, though. In the old networks, those are running on just standard Linux boxes. And we were talking 4G network. I'm not going all the way back to 3G networks. That was a little bit more proprietary. But 4G networks today, they're normal Linux boxes. And then the vendor put some software on it. So the patches are available. Everybody knows what SUSE Linux patches or whatever flavor you have you need to install. But the vendors of those, all of them, Ericsson, Nokia, Huawei, ZTE, wherever you look in the world, they're very reluctant changing their systems. They have drops once or at most twice per year. And sometimes they include security patches. But even creating such a build sometimes can take 6 months. So you're always 1 year behind on Linux patching. If you're 1 year behind, you might just as well not patch. There's always a critical bug every single year, right? So it's a reluctance of the vendors that made mobile networks so far basically unpatched. Now that all goes away, right? Now you, as the operator, become the vendor. You're pushing everything into these CI/CD pipelines and the Artifactory. You deploy yourself onto those 10,000 units. So in theory, you can do any patching you want. The problem is each of those 10,000 functional units is very, very specific. It's a very stripped down Linux flavor that's just fit for purpose for whatever that one little thing is it's doing. So there are no patches available. It's not SUSE Linux anymore. It's not Red Hat. It's none of the maintained distros. Somebody created this for one purpose, and that team probably doesn't have the knowledge of a Linux distribution to keep pushing patches. So today you can patch easily, but nobody's giving you patches anymore, right? So for the foreseeable future, mobile networks, at least in parts, will stay entirely unpatched, right? So segregation is key again, and segregation comes through good container configuration, like we said earlier. Let's look at one counterexample, though, something that was always easy, remains easy, and that is privileged access management. I mean, if you take nothing away from today, container configuration and privileged access management, those are the two things you need to do. Whatever industry, whatever infrastructure is completely agnostic, do those two things, right? Privileged access management basically means intermediating between where all the users are, or all the hackers are, and the most privileged ports, so your SSH ports or whatever proprietary configuration ports you have. And there's really mature systems out there. They used to cost a lot of money. Now there's even open source alternatives. The Apache Foundation, what's this called? Guacamole, I think, right? Pretty mature. Just use that, right? If you don't already have a PAM system because 5 years ago somebody told you there's no budget for it available, now it's free. Do it now, right? And yeah, it was easy before, it's easy now. Again, everything is just Linux, right? You disintermediate between user networks and SSH ports. As easy as that. Last example, endpoint detection. Surprisingly, that has gotten harder now that we got more modern, for the same reason we mentioned with the patching, right? So deploying a good endpoint detection tool, or even just a good logging solution, let's say Wazoo. People like Wazoo here? I love it, right? So if you have a fleet of Linux computers, just put Wazoo on there, download some best practice rule set. You're already in order of magnitude more likely to detect hacking attacks. Now that, again, doesn't work if you're running some stripped-down version of Linux and different in every single of these containers, right? Wazoo won't even know where to start collecting data from or what's relevant. So again, you are in control of your infrastructure now, but you also are responsible for now building the security tooling that works in that infrastructure. It's not that straightforward. So overall, some things have remained hard, some have always been easy, some things have gotten surprisingly harder. So as you're moving into these cloud environments, as you're adding those hundreds of people in some third-party companies adding automation to you, don't forget to also add security competence, add really that eagerness to stay up to date. And if you don't know where you stand yet, red teaming, from my experience, is the way to find out which of those apply to you. Chances are all of them, right? But as you mature, maybe patching or user access or whatever else will move more into the foreground, because it keeps then coming up in these exercises. And with all of this, I hope I've updated you not just on how 5G networks do require a lot of security testing. And if you're looking for a new challenge, do look into that. There's definitely more testing to be done right now than there's testers available, and that's globally. Right? But also, if you're not interested in mobile networks at all and focus on something else, these lessons learned hopefully will allow you to build more secure infrastructures and test them very thoroughly. And with that, I'll conclude, and I hope that some of you will be brave enough to ask some questions. But first of all, thank you very much. Yeah.